Good afternoon. This is the third installment for Module 1 for the economics or the macroeconomics class, but it's called Econ 24001 at Fisk University. Thought we'd talk for a few minutes today about just what are the tools of the economist. So basically, as an economist, you're going to be trying to determine relationships, hopefully causation, but relationships in general between or among variables. And basically, if you're an economist, there I guess, multiple venues or multiple types of analytical work that you're going to do, multiple ways of determining relationships. And basically, especially if you're in academia, you are creating theories, you're testing them, you're trying to generate publications, which is going to affect your tenure, or at least you hope it'll positively affect your tenure. If you are not in academia, you'll still be developing hypotheses, trying to create theories, not so concerned about the publication route, because if you're in a job in the private sector, you don't have a lot of time to do journal articles. So you are more focused on either forecasting or doing analytical work. As an example, as a graduate student at Ohio State, I worked part-time at the Ohio State Hospital and spent a good deal of my time there, either in the business office, medical records, admitting, and most of my time was spent trying to develop models that would either improve efficiency, models that would improve revenue, models that would help physicians improve the turnaround time from the time the patient was discharged until the time the business office got the medical record and could turn around and build the payer or the health plan. So spent a lot of time there. First job out of graduate school really was the United States Department of Agriculture. I happened to be in the branch that studied cereal grains. My particular cereal grain was rice. So I spent a lot of time developing models, trying to determine, future price of rice, quantity of rice that would be consumed by individuals, not only in the United States, but in other parts of the world. Also trying to develop and trying to understand the global impact of rice production, not only on the price and quantity of rice production in the United States, but also trying to forecast the impact of global rice production on other types of, alternative carbohydrate sources, cassava, potatoes, along those lines. Once you got out of, or I got back into healthcare, a lot of my work was spent either in medical informatics, medical economics, trying to identify or forecast future healthcare expenditures from the health payer or the health plan side. And a lot of that time was actually spent trying to determine the causation or the relationship between hospital admissions and, were they affected by, or how they were affected by different age groups of the population, how they were affected by different regional interactions, how they were affected by the actually disposable income of the covered population for any given health plan. So spent a lot of time doing that, and that's what economists find as far as tools of the trade and what they're going to be looking for. A lot of the work I did was early on was either in SAS or some of it in the very basic. I could use Excel to do, and then there are a multitude of different types of analytical. Alteryx is one that is being used currently. So just a lot of different software packages that you can use to work through the number of iterations that you work through when you're trying to do a forecasting or where you're trying to complete a particular project. One thing that I did is the position that I had at Blue Cross Blue Shield of New York was I managed a SIU, or a Special Investigations Unit, which focused on providers that were fraudulently billing for services. They could be upcoding on the claims to get more money. They could be billing for services that were never provided. And a lot of that work from an economic perspective was focused on pulling random samples using, at that time, rat stats, pulling random samples of provider claims. Once you got the random sample pulled, then you would take and review the claims and then extrapolate the total dollars that had been fraudulently billed across the entire pool of, or the entire population of claims that a particular provider had. So that's more of a, I guess, empirical or more of a day-to-day use of economic tools. But what economists typically do is they are looking at variables, and a variable is, anything that can change. It's days of the week, it's age of individuals, it's disposable income. Those are variables. So it has a change. A constant variable, there's no change. So you're looking at, and both variables, depending on what your forecasting model is using, can be equally important. But as far as a constant, 7 days in a week, 24 hours in a day, 60 minutes in an hour. I think the book talked about, I guess it was, they talked about Newton's laws of motion. So these are constants. And so that's what economists are faced with. And economists also are looking at the scientific methods, similar scientific method that you might be used in biology or biotech world, where they're trying to develop new drugs, chemistry class, scientific methods where you're developing an hypothesis and you're turning around and trying to test that hypothesis. Always remember that, and we'll get into it a little later in another module, but when you're talking about hypothesis, you're looking at a subset of a greater population. And that hypothesis is nothing more than just your best guess or somebody's educated guess that you're trying to develop a theory from or trying to develop a law from. So you're putting forth your best guess. You're trying to determine those variables that impact your hypothesis, either positively or negatively. And at the end of the day, you're trying to test that hypothesis. And what you find is a hypothesis, it's relationship between two or more variables. And again, you hope it's causation, or you hope that's the result of causation. But what you find on a hypothesis testing is you can never accept a hypothesis. You can only reject it, or you can say fail to reject it, because you're pulling a subset of data from a larger population. And who is to say at some point, either now or some point in the future, that there won't be an occurrence that will reject your hypothesis? So most times when you're testing hypotheses or trying to develop your models or your tools, you are hoping to have enough occurrences so that individuals fail to reject it. And if it's a widespread testing and it wins kind of general acceptance, it's usually considered a theory. And it becomes a law when it is virtually universal acceptance. But even in a law, it's never proven as true, and you never accept it. You always fail to reject it, because you never know when there will be that one occurrence that will cause it to be rejected. At this point, I think I'm going to stop I'm going to stop this iteration of the model. The other one gets a little more detail into the models of the Economist, and I think I'm going to break this into 2 sections to make it a little easier to understand. So that's it for this particular piece of the puzzle when we're talking about Module 1, and see everybody in a few minutes.